In day 2 of 3.4, we're going to now solve logarithmic equations instead of exponential equations. Now, when we solve logarithmic equations, if we can use that one-to-one property, we want to be able to use that. So like if we had log base 5 of x equals log base 5 of 4, because the bases are equal, that means the insides would be equal as well. So we want to look out for that. And then we also want to make sure that we remember that the log with no number written there is an invisible 10, and that the ln is the natural log with base e. So for example 1, we have the natural log of x plus the natural log of 5 equals 2. Well, we know from our rules of logs that we can condense those and rewrite this as log base e, or ln, of 5 times x, because I'm making it into one log, and that equals 2. Now, once we get the log by itself, we want to switch it to exponent form. So this is, again, is really the natural log of 5x equals 2. Now we're going to switch this to exponent form. Our base is e, so e to the second power, because logs equal exponents, equals 5x. In the calculator, if I type in e to the second power, or e squared, that is going to give me 7.389. 7.389 equals 5x. And then when I divide both sides by 5, x is going to equal 1.478. Oops. X equals 1.478. Now, again, we want to make sure that we can have this be a value. So we have to look and see, can we take the log of this number? Well, if we just have the ln of x, that means x has to be greater than 0, because we can't have 0 or a negative number in there. And our value of 1.478 is greater than 0, so it's in the domain, meaning that is a solution. Now over here we have two logs, log base 3 of x plus log base 3 of x minus 8 equals 2. So for this part right here, x has got to be greater than 0, and the x minus 8 part tells us that x has got to be greater than positive 8. So we have two logs again being added, so we can rewrite this as a multiplication problem. So log base 3 of x times x minus 8 equals 2. Then we can change this to exponent form. So we have x times x minus 8 equals 3 to the second power. Distribute the x, so we have x squared minus 8x equals 9. And then when we subtract 9 from both sides, this is going to give us x squared minus 8x minus 9 equals 0. Well, that's a quadratic that we can factor. Two numbers that multiply to negative 9 but add to negative 8. That's going to be x minus 9 and x plus 1. That makes our solutions x equals 9 and x equals negative 1. However, x equals negative 1 can't be a solution because up here we said x has to be greater than 0. And x has to be greater than 8. The only one that fits that is x equals 9. So this is an extraneous solution. All right, now letter C, this is one where we don't have a base written, so it's an invisible 10. We have the log by it. We have a single log by itself, so we don't need to do any properties of logs. So our base is 10, so it's going to be 10 to the second power equals x plus 3. Well, 10 to the second power is 100 equals x plus 3. And then when we subtract 3 from both sides, we get x equals 97. Now again, up here, we know x has to be greater than negative 3, and our value of 97 falls within that, so that is an answer. All right, now letter D, because we have x plus 1 in the log, x has got to be greater than negative 1. The first thing I'm going to do is get rid of the 1/2 in front by multiplying both sides by 2. That gives us log base 2 of x plus 1 equals 4. Now we can switch this to exponent form. 2 is our base, so 2 to the 4th power equals x plus 1. 2 to the 4th is 16, so 16 equals x plus 1. And then we subtract 1 from both sides, x equals positive 15. And that number is greater than negative 1, so we know that works in our domain. Now letter E, on the next page, we have log base x of 12 minus x equals 2. Well, because it's 12 minus x, that means x has to be less than 12, because anything bigger than that is going to give us a 0 or a negative in the log. So let's switch this to exponent form. Our base is x. X to the 2nd power equals 12 minus x. Well, we need to make this equal to 0 because it's a quadratic. If we add x to both sides and subtract 12 to both sides, we have x squared plus x minus 12 equals 0. Let's factor this. So we have x minus 3 times x plus 4 equals 0. So our solutions are going to be x equals 3 and x equals negative 4. Now, if we look back up here, both of those numbers are less than 12. But remember what we said about the base of an exponential equation. Back at the beginning of the unit, we said that our base of an exponential function has to be bigger than 0 and not 1. The base of the log is the same base for your exponential equation. So we also have to account for x has to be greater than 0 and x cannot equal 1, because that is the base of our exponential function that corresponds with this log. So that means even though negative 4 would work up here, it doesn't work over here for that domain. So we can't have negative 4 as an answer. So our only solution is positive 3. Now you only have to worry about this when your base of the log is x. All right, now with letter F, we have, again, 2 logs. So we're going to have to use our properties of logs, but for this log, x has to be greater than negative 1, and x has to be greater than 0. So the most restrictive one is x has to be greater than 0. So let's combine this now. So we have log base 4 of x plus 1 over x, because we have a subtraction sign there, and this is equal to 1. Now we can change this to exponent form. Our base is 4, our exponent is 1, and it will equal x plus 1 over x. Well, we have to get x by itself, so we're going to actually multiply both sides by x to get rid of x in the denominator. So we get 4x equals x plus 1. Subtract x from both sides, giving us 3x equals 1. And then divide both sides by 3, we get x equals 1/3. And 1/3 does fit in our domain up here, so that is a viable solution. All right, these last two here. Again, we already have the log by itself, so we can rewrite this now in exponent form, ln, or log base e. So it's going to be e to the 2nd power equals this stuff right here. the square root of x plus 5. Well, to get rid of the square root, we got to square both sides. So we're going to square both sides. And that's going to give us e to the fourth equals the square root of x, sorry, not the square root of x plus 5, because we square it, the square root cancels, so we're left with x plus 5. So then in the calculator, when I type in e to the fourth, and again, in case you've forgotten how to do that, second natural log 4, and we get 54.589. 54.589 equals x plus 5. And then when we subtract 5 from both sides, that's going to give us 49.5. Oops, this should have been 98 right here. Now, we do want to make sure we can substitute that back in. When we take the square root, we'll get a positive number. And since we have a positive plus a positive under the radical, we know that we can take that square root without any problems. Right, now, the last one. We have a log on both sides of the equation. So for this log, we know x has to be greater than -5. For the next log, x has got to be greater than +1. And for this one, x has got to be greater than -1. So when we have logs on both sides of the equation, we want to simplify it so that we have a single log on the left side and a single log on the right side. Well, on the left side, we already have a single log. And then on the right side, we're going to condense this into the natural log of x minus 1 over x plus 1, because there's that subtraction sign right here. So that means the x plus 1 part goes into the denominator. Well, since we have the ln on both sides of the natural log, that means the insides must be congruent, or the insides must be equal as well. So we have x plus 5 equals x minus 1 over x plus 1. So then we'll solve this, multiply both sides by our denominator here, x plus 1. So on the right side, those cancel. And then we have to FOIL this. X times x is x squared. X times 5 is 5x. Then plus 1 times x plus 1 times 5. And that's going to equal the x minus 1 there. Combine our like terms. So we have x squared plus 6x plus 5 equals x minus 1. Now, when we bring over the x and -1 by doing the opposite, we get x squared plus 5x plus 6 equals 0. And then we can factor that to x plus 3 and x plus 2 equals 0. So then our potential solutions are going to be x equals -3 and x equals -2. However, up here, x has to be greater than +1. Both of these do not fit that, so that means both don't work, so there's no solutions. All right. So all these problems, what you're trying to do is get the log by itself. Okay, divide, multiply both sides by stuff, condense logs until you get a single log on one side and a number on the other side. The only exception was letter H, where we had a log on both sides, and because it was the same log base, we could then set the insides equal. So thanks for watching the video. Make sure to like it and subscribe.